Hi Level 3, welcome to 3.4 Atomic Structure and Bonding. This is Lesson 3 Part C. It's just going to be a quick one. I didn't quite get to finish a couple of concepts. So here's a question I'd like you to look at. I'd like you to compare the size of Fe2 plus and Fe3 plus, which will be smaller. So if we have a look here, I've answered it just so I can talk you through it. So you weren't asked about the atom here, okay? So this was not asked, but it's just to give me a bit of a discussion point with you both, with you all. So if you look here, Fe2 plus has the electron configuration 3d6 and Fe3 plus is 3d5. So which one do we think is going to be smaller? Well, this time here, we're not talking about the loss of an entire energy level, okay? So we're not talking about that at all. They've both got electrons in 3d here, okay, or energy level 3. It's just that this one here has only got 5 electrons in the d, whereas though this has got 6. So because there are less electrons, okay, there's going to be less electron-electron repulsion in that valence shell, which is going to make the size of the ion smaller. Please remember that nuclear charge will remain the same because they are the same element. Okay, so the reason why Fe3 plus is smaller is there are less electrons in the valence shell. They're repelling each other less. Just as a bit of a comparison, because this is quite a good one here, if you were then to compare the size between Fe and Fe2 plus, then the answer would be that Fe would be larger because it's got the extra 4s energy level, okay, so or electrons in the 4th energy level, and therefore the valence electrons would be further from the nucleus with greater shielding by inner shell electrons, making the size of the atom larger than the ion Fe2 plus. Okay, so that's just to give you a bit of a comparison. So this would be discussing loss of energy level, and if you talk about loss of energy level, you must talk about distance being smaller for this one here and less shielding, whereas though this one here between these two, there's no loss of energy level, it's just a reduction in electron-electron repulsion. Any questions? Pop them on Teams. So here's a bit of a summary of atomic and ionic radii. So atomic radii, you can see the yellow gets smaller as you go across the period, and the yellow get bigger as you go down the group. So that's the general trend. And then you can also see here that cations are always smaller than their atoms. And yeah, I don't have any anions there, but there you go. Okay. So here's a bit of a summary task to make sure we've got this stuff, okay? So compare the size of oxygen, sulfur, and magnesium. Okay, so you're comparing oxygen, sulfur, and magnesium. My hint whenever you're given a question like this, by the way, this was an NZQA question, you want to compare two that are in the same period and then two that are in the same group. In my opinion, it makes things a lot easier. So pause now and give it a go, but I'm going to run through the answer. So here are the electron configurations, okay, but you don't really need it. If you just start with these two that are in the same period first of all, I think it makes things easier. So if we look at magnesium and sulfur, sulfur will be smaller than magnesium, and the reason why is because sulfur is further across the period. It's got 16 protons compared to magnesium's 12, which means it's got a greater nuclear charge. As they're both in the same energy level, the shielding by inner shell electrons will be the same. Because there's more protons, the electrostatic attraction between the nucleus and the valence electrons will be greater, pulling in those valence electrons more, making sulfur smaller. So I'll just show you my answer now, and I've just said all of that. Okay, perfect. So now that's part the answer, and now we've got to talk about, so now we know magnesium is going to be bigger than sulfur. Oops, I've got that round the wrong way. Oh no, I haven't. There you go. So then we've got to do oxygen and sulfur. So because oxygen is further up the group than sulfur, oxygen has got less energy levels. Oxygen's got 2 energy levels and sulfur's got 3. So sulfur's valence electrons are further from the nucleus. There's greater shielding by inner shell electrons. This means the electrostatic attraction between the valence electrons and the nucleus will be less, which means that the size of the atom will be greater, which means that sulfur will be bigger than oxygen, and therefore you have ranked them. Okay, and there's my last answer. Okay, so magnesium will be greater than sulfur, which will be greater than oxygen. Hopefully that all makes sense. If not, put a question on Teams. Summary task 2, this one's a little bit harder, always kind of trips students out a bit. It says order the following from largest to smallest, atomic/ionic radii, and explain why. So today you are comparing Fe and zinc with the iron Fe2+. So it's probably, in my opinion, easier to talk about the two atoms first and then compare to the iron, but up to you. You can answer it however you want, really. If we just compare these two atoms, they're both in the same energy level, which is energy level 4. So therefore, shielding by inner shell electrons is going to be the same. Zinc's got 30 protons, iron's got 26 protons. So zinc has got a greater nuclear charge, and therefore zinc's electrostatic attraction between the valence electrons and the nucleus will be greater. Therefore, it's going to pull those valence electrons in closer, and therefore the size of the zinc atom will be smaller than the iron atom. Okay, so that means that iron is going to be greater than zinc. So I'll just show you my answer for that. I just did the electron configurations as well. Sometimes that's really useful just to kind of give you a bit of an insight. And when you do that, but you do have to be quite careful here because we're not comparing between these two, atom and iron, which we could do this for in that last iron 2 plus iron 3 plus example. Be careful you don't get confused. With these two, remember, yes, this has got more electrons in the 3D than this one, but because zinc has got a greater number of protons, it will be smaller, and that's what we just discussed. And then the reason why I've done these electron configurations is you can see both of the atoms have got electrons in energy level 4, which Fe2+ does not have. So that means that Fe2+ has lost that outer energy level, so Fe2+ will be the smallest out of the 3 because it's not got that energy level, which means its valence electrons are now closer to the nucleus with less shielding by inner shell electrons, and therefore will be smaller. Okay, so all of that's written here. Okay, feel free to pause and have a proper read through and let me know if you have any questions, but we have actually just gone through all that. Okay, that's the end of lesson 3. We'll pop back in a second to do lesson 4 on ionisation energy.